Good morning.
Good morning.
On behalf of the Department of Computer Applications, I welcome everyone to the second day of two-day webinar series on emerging trends in data science. Before commencing the sessions, I request all the participants to mute their audio. The participants can ping their questions in the Q&A box, which will be answered at the end of each session by respective speakers. Today we have two sessions. First, we have session 2, Applications of Data Science by Dr. Sejal Santosh Nimborkar, followed by session 3, Pattern Representation to Document Images by Dr. Sahana Gowda. It gives me immense pleasure to introduce speaker for session 2, Dr. Sejal Santosh Nimborkar. Dr. Nimborkar is an associate professor at B&M Institute of Technology. She has more than 18 years of industry research and teaching experience. She holds ME and BE degrees in Computer Science and Engineering from University Visvesvaraya College of Engineering and Gujarat University respectively. She was awarded PhD degree in Computer Science and Engineering from Bangalore University. She has published 26 papers in refereed international journals and international conferences. She received an Outstanding Paper Award at the 2015 European Conference on Data Mining. She has published a book entitled Web Recommendation Systems in Springer publication and filed a patent, System and Method for Image Analysis and Summarization. Dr. Nimborkar has also received project grants from Karnataka State Council for Science and Technology, KSCST. Her research interests include data mining, web mining, sentiment analysis, and IoT. I take the privilege in welcoming Dr. Sejal Santosh Nimborkar to take over the session. Over to you, madam.
Thank you. Thank you for your nice introduction. I'll share my PPT, then we can start.
Yes, ma'am.
PPT is visible to everyone, right?
Yes, ma'am.
Yeah. So thank you for giving me the opportunity to present applications of data science. So we'll start with first. Okay, I think it's loading. Yes. So we'll start with what is data science. And then when I'll talk about data science, I have to talk about data also. So I will talk about the structured and unstructured data. Then we will talk about raw data. Then I'll start with the applications. And I will talk in detail about the text summarization, video summarization, and recommender system. So I'll just start with what is data science, just as an introduction. So data science is about extracting useful conclusions from large and diverse data set through exploration, prediction, and inference. Exploration involves identifying patterns in information. Prediction involves forecasting future event. Inference involves quantifying our degree of certainty. Will those patterns we found also appear in new observation? How accurate are our prediction? So here we are basically exploring the data and we are finding the knowledge out of the data. Then we'll see that data science, when we talk about data science, it involves many other methods. So that it involves statistics, data analysis, machine learning, domain knowledge, and the related method in order to understand and analyze actual phenomena with data. Statistics is a discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. Data analysis is the process of inspecting, cleansing, transforming, and modeling data. Machine learning is the study of computer algorithms that improves automatically through experience. Domain knowledge is knowledge of specific specialized discipline or field. So domain knowledge is also here very important because statistics, data analysis and machine learning will use to extract the information. But whatever the extracted information or which information we need to extract, that comes under domain knowledge. So any data science team have one domain knowledge person who has knowledge about the particular domain, and he will assist that which type of knowledge or which type of information we need to extract from the data. Then why data science is required? So here we were talking about data, right? So what is data? So data around
I apologize for there is some kind of technical problem. Ma'am will be connecting within a short while.
हुआ हाँ yeah. Now I think I can come no क्या हाँ देखा मैंने मेरा लेकिन मुझे परमिशन नहीं मिला स्टार्ट वीडियो करने का आया
September 1st.
yeah sorry for the disturbance
Yes. No.
yeah it's loading PPT is
Yes.
loading. So again, I'll start with structured and unstructured data. So structured data are data that can be stored in a table, and every instance in the table has the same structure. My voice is clear?
Yes, ma'am. Now audible.
Yeah, but some echo is coming? No. Okay.
No, ma'am.
So we'll take one example. Say we'll take one population where we have information about the people. So when we will talk about any person, then we can describe one person by his name, age, date of birth, address, gender, educational level, job status. So these all are called attributes for that person, and person is from the world. So I have previously told if we have data from the world, so that world a person belongs to world, and the person can define by attributes, and that attributes are name, age, date of birth, etc. And these attributes are same for all the person in a world, and that so all the person have the same structure here. That is why this is called structured data. Structured data can be easily stored, organized, searched, recorded, reordered, and merged with other structured data. Now we'll see unstructured data. So usually when we'll talk about data science, or when we talk about any application in real world, mostly we have unstructured data. So we will have to work with unstructured data. So unstructured data are data where each instance in the data set may have its own internal structure, and this structure is not necessarily the same in a set of web pages. So in each web page in having a structure, but this structure differing from one web page to another. So if we will take say 2 web pages, in one web page maybe image is at the rightmost corner, and in another web page the image may be at the leftmost corner. So both have image have same structure, but the web page, when you talk about the web page as a data, then they have different structure. Then we can talk about the human text, that is email, tweet, text messages, post, novels, also can be considered as unstructured data. And they are collection of sound, image, music, video, and multimedia files. So these are all unstructured data. The variation in the structure between the different elements means that it is difficult to analyze unstructured data in its raw form. So when we will process on in data science, we have to convert these unstructured data into structured data first, and then we will process with the data science. So we can extract structured data from unstructured data using technique from artificial intelligence such as natural language processing and machine learning, digital signal processing, and computer vision. So next is raw data, and there are 2 categories in that: captured and exhaust data. So what do you mean by captured data? So captured data are collected through a direct measurement or observation that is designed to gather the data. So if you take any survey, or if you conduct any experiment, if you take data from sensors, so these all are the captured data. These are the example of captured data. And exhaust data are byproduct of the process whose primary purpose is something other than data capture. So we are capturing the data and then we are interpreting in a different way that data, and that is called exhaust data. We'll see one example. The primary purpose of many social media technology is to enable user to connect with other people. For every image shared, blog posted, tweet retweeted, or post liked, a range of exhaust data is generated. So this is our daily activity. We'll share the image, we'll write the blog, we'll tweet, right? So this is the general activity of the user on the net, and through this information we'll find out or we'll gather exhaust data, that is who shared the image, who viewed, what device was used, what time of the day, which device was used, how many people viewed, liked, retweeted, and so on. So these are the exhaust data, and these exhaust data are used for further business purpose. So we can say that if some image is shared, says that is product image, it is shared, and many people viewed that, that means that person is liking that product and he is planning to purchase that product. We can infer the information like this by using shared images and then viewed images, right? If some person shared the image, some person viewed the image, and the interpretation we can take in terms of business is that the person who has viewed the image likes the product and he is planning to purchase that product. The primary purpose of Amazon website is to enable user to make purchases from the site. Each purchase generates volume of exhaust data, what item the user put into her basket, how long she stayed on the site, what other items she viewed, and so on. So data science has traditionally focused on captured data, and exhaust data can be used to reveal hidden insight into situations. So now we'll talk about various applications of data science. So here I will talk in terms of the input. So which data types will use as an input, and then with that data, which type of information you can collect and where it is used. So basically we have text, image, audio, and video. So these are 4 major types of data. So if you take any web pages, There can be a text also, there can be an image also, right? So these are the general data set what we will use. So first we will take text. So if I'll take text data, how I can use the text information in any of the application. So first we can mine the text. So text mining extracts the useful information and knowledge hidden in the text content. So risk management, then knowledge management, customer care service, content enrichment, spam filtering, social media data analysis, and text summarization. So here I have done text summarization in blue color. So I will be talking in detail about the text summarization later. So here when we talk about the text, so risk management. So if some article we are reading about some risk management, then we can infer the information that how it is risky. Then we will get the knowledge management. So if you are reading any information about the data science and somebody has given you 100-page for data science, and then it is difficult to read all the 100-page and understand. So if you extract the information from that 100-page and somebody will give you 10-page, that will be easy to understand and easy to read with less time, right? So that knowledge we can extract from the text, right? So that is how text can be used in various applications. So here I have listed few. There are many more applications in the text data. Then we'll take image as a input in data as a data. Then we can have medical or biological image processing. Then we have space image processing. Then automatic character recognition we can do, fingerprint, face, iris recognition. So it can be used in various applications, right? Then we have audio. If you have some audio, then what all audio in different application, how we can use that. So we can identify Parkinson disease prediction. Then if we have song as a data, so that's we can classify the genre of the song. Then we can automatic music tagging can be done. So based on the music, what is the genre, then we can tag that this music is about this, right? So we can classify the music here with the audio. Then we'll take video. So in video, if we have any application where we have video, we can take as automatic vehicle number plate detection. So if we have video in, say you just think of a very big apartment where many vehicle movement is happening and we wanted to restrict the outsider, then this application is very useful, that automatic vehicle number plate detection, because already we can store the information who is staying in that apartment. That vehicle number we can store, and then other than that vehicle number, anything is identified, we can say that that person is outsider, right? So that is how we can do automatic vehicle number plate detection. Then video surveillance. Everywhere nowadays we are using video surveillance. Then video summarization, object detection, object tracking. So these are the different applications based on the input of the data. Now next, in industry, how data science is useful. So we'll take one, finance. So in finance, data science can be used to detect the prediction of equipment effectiveness and price optimization. So prediction of equipment effectiveness in terms of how much time this equipment will last. Because then how we can use this information, we can use this information that this much time my production can be stopped because this equipment will work for certain hours, right? So accordingly we can plan for production. Then next is real estate. That can be used for rent optimization and tenant retention, because every 3-4 months if tenant is keep on changing, then it's difficult to keep track. So in real estate we can use data science for tenant retention and rent optimization. Then in healthcare, identifying and predicting disease. So if any cancer or any other disease, if the input data is given to you, then in that case we can predict the disease at which level, initial stage, and then anyway doctor will help us for curing that disease. Then personalized healthcare recommendation. So every time when we will go to one doctor, then he will be having all the record, and if he has he has purchased any data science application, then we will instead of going to doctor, that application itself will tell us that this is your time to take the medicine, right? So that is your personalized healthcare recommendation. So it recommends you. Now you have to go and visit the doctor for such results. So that's how we can use data science in healthcare. Then internet search, which we use every day. So in internet search, it is targeted advertising and recommender system. So in targeted advertising, if any person is searching any information on the net, then based on the information what he is searching, other advertisement agency can target his advertisement to put for that search, so that that person can purchase his product, right? So that is how this will use as a targeting advertising. And recommender system, anyway we will see in detail. The next is human resources. So which employees are most likely to leave? Employees performance, decide employee bonus. So if we have in human resource, that person, when any employee, when he joined, how long he is there with the company, then how much hours he is working, how much extra hour he is working, all the information we can use, and we can apply the data science algorithm on that, and we can find out the information that we have to give him bonus, or how his performance is, or he is staying with us, or he is leaving the company. Then in road travel, street light. So street light uses data science to model traffic patterns for car, bikes, and pediatrician. So in street light, we capture the traffic movement, right? And then that can be used that in certain time, in this traffic signal, many vehicle will be there. So we have to divert the vehicle, or we have to go through the same thing, because the same vehicle movement will happen for the next street light. So that is how we can use data science for traffic, to identify the traffic pattern, and then we can use that later for diverting traffic. So right, next is Uber Eats. So Uber Eats is using data science for optimizing its full delivery. How it does is, it optimizes the full delivery process. So the team has to predict how every possible variable from storm to holiday rushes will impact traffic and cooking time, because they have to deliver the food, right? So it should be on time. So based on some holiday, rushes will be less, or when sometimes in peak hour, rushes will be more. So how much buffer time they should keep for delivery, so that they can predict and they can optimize the delivery process. And they are using this, Uber Eats are using data science for delivery. Then in sports, so Liverpool Football Club is using data science that calculate how every pass, run, and goal attempt influence a team's overall chance of winning. So you will be having, I mean, Liverpool Football have many data of each play, and then based on that they will calculate, so that this team can win. And they are using this data science, they are using to calculate all the information. In retail, identifying profitable customers and understand the reasons for their loyalty, manage the brand on social media. So retail, every day we are using Flipkart and Amazon, right? So there you can see, more than what you want to search, they will give you only recommendations that these people are buying this item together, or last year purchase is this one, so maybe you are likely to buy this, right? So this information they give to increase their profit also, and to retain their customer. That is very important in retail business. So next I'll start with text summarization. So we'll see which type of technique we'll use. Simple steps I will show you that how text summarization can be done, and then what all possible algorithms we can apply on it. So what do you mean by text summarization? And when I'm talking about text summarization, it is automatic text summarization. So machine will do, you just give the document, machine will give you summary out of it. So automatic text summarization is the process of finding the most informative sentence in a document that represents the most important or relevant information within the original content. So automatic text summarization can be implemented by using two approaches, extractive and abstractive. So what is extractive method? Extractive method comprises of existing sentence and words from original document representing meaning of text. So it takes the sentence and word which is present in the document and it gives you summary. So what is the process for that? So first you have to give a document to the model, right, as an input. Then it calculates the sentence similarity. Then the similarity will be given with some weight, and then based on this weight you select the sentence with higher rank, and that selection of sentence with the higher rank will give you summary. And the method of abstraction generates the summary by using internal semantic representation and natural language processing technique. So it is different from the extractive. In extractive, the existing sentence and word is used to represent the summary. But in abstraction, it understands the context and then semantic of the sentence and it creates its own summary. So you give here input document as an input, then understand context, it's semantic, and then it generates its own summary. So many work has happened already in extractive method, but in abstraction, it is less work. So now, how to start to do the text summarization? So I have already discussed with you about the raw data. So any data what you will get is in terms of raw data when you give it to model, but we cannot directly give it raw data to the model, so we have to pre-process it. So for text, what pre-processing is required? So you have to tokenize the data, normalize the data, and you have to remove the noise. So in tokenization, it's splitting strings of text into smaller pieces or tokens. Paragraph can be tokenized into sentence, and sentence can be tokenized into word. In normalization, put all the text on the level playing field. That means you convert all the character into lowercase, right? Because here system need to understand the each letter. So some capital letter, some small letter, it won't understand. So you convert all the character into lowercase. Then noise removal. So you have to clean up the text. That is, you remove the extra white space. Then stop word removal and stemming. What do you mean by stop word removal? If you have heard, I think yesterday's presentation, this was covered in that. So stop word removal is a, the, and all the words are removed in the stop word removal. And in stemming, if you have ing after any word, then that is removed. So you can have the exact meaning of that word. Then next, now once pre-processing is done, we have now words out of the sentence or out of the document with us. So now that word again we cannot give it to your model because your model understands only numerical values. So we have to convert that word into vector or with some number. So how we can do that? So that is called word embedding. So word embedding is to create word feature vector where words or phrases from the vocabulary are mapped to vectors of real numbers. So word embedding models are, so I'm not going more in detail, I'll just introduce the embedding models of words, term frequency, inverse document frequency, continuous bag of word model, and skip gram model embedding, that is skip gram. Then Next is few pre-trained models are available for word embedding. So word2vector is by Google, and that is really good. So you can directly use word2vector to convert all your words into vector with some weight or numbers. Then Glowy is by Stanford. Fast text is by Facebook. Then you have PioCare also embedding one method. Then Node2vector embedding based on random walk and graph. So these are available word embedding models. So you can try this. Next, now vectors are ready. So next, what you have to find out is sentence similarity. So how we can find out? So some sentence similarity measures I have listed here is Jacquard similarity. You can use K-means algorithm, then cosine similarity, then latent semantic indexing, that is LSI plus cosine similarity, then latent Dirichlet allocation, LDA plus Shannon distance, then Simon's Manhattan long short term memory, LSTM you can use. So these are the sentence similarity measures is available. Now, once you get the sentence similarity measures, and then you rank your similarity, and then you can extract few sentences from that to generate the summary. So this is about the extractive summary, right? So now next was abstraction. So in abstractions, we have to understand the text first, the knowledge or the information in the text we need to understand, and then we can generate the summary. So pre-processing step and word embedding steps are common, but here in extraction we have to find out the knowledge based similarity, because we need to understand the knowledge out of the text, and then we'll generate the summary. So here WorldNet based similarity matrix is available in the WorldNet similarity package, and all these metrics are defined between concept rather than words. And then we have, these are the scientists Leacock, Lest, Wu, Wrestling, Lin, Jiang. So these have used WorldNet based similarity matrix to find out the knowledge based on the concept rather than the words. So what is WorldNet? So WorldNet is a large lexical database of English. Noun, verbs, adjectives, and adverbs are grouped into set of cognitive synonyms, each expressing distinct concept. Then synset are interlinked by means of conceptual, semantic, and lexical relations. So we can use this for abstraction. So now here I'll show you one code in Python for extractive summary. So you can just see that how the summary can be generated from document, right? So here I have given as a input is mission reviews, and then you can see how it works. So here in NLTK you can use similarity matrix. Out of that, then you generate the summary. And then here I have given mission text. Then this one is the sentence similarity score. So in between you can see here some values are there, right? 0.47, 0.46. So these are the value given to that sentence weight, and based on that weight we can generate the summary. So that summary is hardly 10 lines. Now, what are the research issue and text summarization? So first thing is handling unstructured data. So we can just think of the one textbook you give as a document, and then in that how many words are there, right? So to handle that it is difficult. So your model you have to develop in such a way that handles the unstructured data, that is that is in terms of matrix. If you convert that into matrix, then your matrix length will be big. So that is the reason that should your model should handle that. Then you have to capture the linguistic information. Then you have lack of coherence in generated summary. So I'll just give you one example how it is. So Jack is eating chocolate and Jack bought chocolate. So if Jack bought chocolate, he is eating, right? So when you generate the summary, which sentence should come first? Jack bought chocolate and Jack is eating chocolate. So it should be Jack bought chocolate and eating chocolate, right? Or and eating. So that can be summary. So rather than making two sentences, it can be generated in one sentence. So that is important when you generate the summary. Then deep understanding of the concept required to improve the quality of summary. So we'll take one example. See, company A acquires company B. Company B acquires company A. Company A is acquired by company B. So these are the sentence given. Now, if I have told you we are removing stop words, right? So if you remove A, B, right, then the meaning itself changes. So first, your model should understand the concept behind the text first, and then it should generate the summary. So next, we'll talk about video summarization. So previously we talked about the text summarization where you are giving input as text. Now in video summarization, we'll give input as video. So what do you mean by video summarization? So video summarization is a vital process that facilitates well-organized storage, quick browsing, and retrieval of large collection of video data without losing important aspect. So same here also, when you are giving summary of a video, the important aspect should be present. So take one example, your cricket match, right? And every day you will, every evening after the cricket match, you will get the highlight. So what is highlight? Highlight is your video summary, right? Video summary of your match. So your match will go for 3-4 hours, but your highlight is in half an hour, which covers all the important aspect, like how that person was out, how who caught the ball, right? It was run out. So all that important aspect should be there, and your model should generate it automatically, right? Rather than some person will sit for 3 hours and edit and then he remove redundant information. Rather than, your model should do that, and that is your automatic video summarization. So the original video can be summarized based on the features present in the video. So what are the features? These features are generally drawn from three modalities: text, audio, and visual. And that a large variety of combinations of features and classification have been explored. So now we'll see how we can do. So here we can, it has basic two steps. We'll short boundary detection. So we have to find out the boundary where we have to include or we have to remove, and then keyframe extractions. So short boundary detection process will divide the video into shorts, and the frame are integrated to form a summarized video. So these are the general information I'm giving you. Next we'll see now what are the steps involved to generate video summary. So we'll give input as a video, then we need to extract the features, then classification of frames and removal of redundant frames. So whatever input video we are giving, first it is converted into frames, and then once you convert into frames, we'll extract the features, and then we'll classify the frames, which is important, which is not important. Then we'll remove the redundant frames. Then again you integrate the keyframes, and whatever you do integration of the keyframes will generate the summary. So now in each step, what all the methods can be used. So for feature extraction, we can use principal component analysis, and in Python this is available. Okay, directly it is available. So you need to know the steps, and you can try with different method, and you can identify which method gives you better result or better accuracy. So for feature extraction, we can use principal component analysis. Then linear discriminant analysis, that is LDA, scale invariant feature transform shift, a histogram of oriented gradient is hog. Then feature extraction method, again you have speed up robust features serve. Then local binary patterns LBP, color histogram. And now new in deep learning we will use CNN, that is convolutional neural network. And for convolution neural network, LXNet, PLESNet, HybridNet, VGGNet, GoogleNet and ResNet is available, which directly you can use for feature extraction. Then next, classification of frames and removal of redundant frames, the next step. So how you can classify? So we can use support vector machine, we can use support vector regression, then we can use CNN with softmax function. And then how you can integrate? So when you are integrating, basically you are clustering that. So we can basic algorithm we can use and check k-means and k-nearest neighbor. So these are the steps involved in summarization. And then if you use deep learning combines classification and clustering based on the number of layers you take as input, right? So how you define, so how deep you wanted to identify the information, so that depends upon the number of layers. So how many number of layers you give as an input, based on that classification clustering you can combine. Next, I will show you one video. So this is original video for 1 minute. So here you can see she has crown on her head, and that crown so he has given it to that next person, right? So which is important aspect? That crown was stolen, right? So this is the original video. And now she understood that she has lost. Okay, now we'll see how the summary should be. She came to know that it is giving, right? So this is your summary, right? So this we have published a paper in 10con. So I'll tell you what we have done. So this is our VNMIT students have done the experiment. So they have taken video as an input, then video frames are extracted, then PCA and LDA method are used for feature extraction, and then that was trained over convolution neural network, then classification of frames and removal of redundant frame, and then by using k-mean and Bayesian network model, integration of frame was happen, and then video summary was generated. So here we have tried different combination of the algorithm. So PCK defined PCA for feature extraction, CNN for classification, and k-means for summarization. LCK is LDA for feature extraction. So here feature extraction technique we have changed, and then CNN and k-mean is constant. In PCBA is PCA for feature extraction, CNN for classification, and Bayesian network. Similarly here, instead of PCA, it is LDA, then again CNN and Bayesian network. So we have tried 4 different models by different combination of the algorithm, and then we got the result of summarized video in terms of the time, summarization time. So these are the videos, 7 videos we have experimented. So these are in seconds. So one video is in 45 seconds, 85, and then how this each technique has summarized the video in how much time, right? So you can see here this is in 12 seconds, 15 seconds, 13 seconds, and 10 seconds. So you can see here the video summarized video time. So it is reduced. Then how many number of frames were removed? Because in one of the step I have told that redundant frame is removed, right? You need to remove the redundant frame, right, to generate the summary. Then only you can make a summary of the video. So here in one video it was 1520 frames were there originally, which is reduced to 405, 507, 439, and 337. So this is how in summary you will get very less frames, right? And then this is the paper. It is action-based video summarization. This is we have published in IEEE Regional 10 Conference 10Con, which is Scopus Index. Next, I'll talk about the recommender system. So now this recommender system every day we are using. So why we required it, right? First thing is, so exponential growth of web information is a challenging task for the search engine to meet users' requirement. So in order to enhance the user experience, the search engine provides various kind of recommendation like query, web page, and images. So I'll show you few example in real world where where the recommendations are used. Already it is in use. So in Google, we will Google every day with some information, right? So I have Google BNMIT. So if I Google BNMIT, then search related to BNMIT, you will get it, right? So these are the information. See, the word is added at the end or in the front, right? So this is your query recommendation. So if you give query as a input and your output also is query recommendations. So this is called query recommendations. Next, in Yahoo, if you want to see some news, you will just give India-China border, then you will get all the recommendations, the out of this which you want to see, right? So no need to type the whole query also, that much quick it gives us recommendations. So this is called query recommendation, because when you give input as a query, it gives you output in terms of different queries which you can use for recommendations. Then here in Amazon, you give, I want to buy say Java book, right? So it gives me Java programming, Java MOS, Java for dummies, all where the Java word is present, right? Then next is personalized. Here I can see it is personalized recommendation. Okay, so I'll just give here D, so it gives me some random queries. Then I will search about Virat Kohli. So that means I'm searching about one cricketer, right? So I will search about Virat Kohli, and then I will search Rohit Sharma. So now Google understands that I'm searching in terms of cricketer. So when I give now D, it gives me personalized search is Dhoni, Dinesh Karthik, right? Deepak Chahal, David, right? So these all are cricketers. So this is called personalized search. Next is here on user search, right? So when you go to Amazon and you don't give any query, still it recommends based on your search. Say recommendation for you in grocery, right? So nowadays we are purchasing grocery from Amazon, so it gives me recommendation. So as soon as I open my Amazon web page, it gives me recommendation what I'm keep on purchasing from the Amazon website. The next is image recommendation. So here I discussed that your recommendation can be in terms of query, it can be user web page recommendation, or it can be image recommendation. So you search on Google, again Google Images Apple, so it gives you first the clusters of all the images you can see down. So here it is about the red apple, it is about the logo, it is about the phone, wallpaper, fruit, right, clip art. So it first clusters based on your search, and if you click on the particular cluster, then it gives you the output in terms of recommendation out of that cluster. Otherwise it gives you general image recommendation. Then on Flickr also, I'll type about sun, then you search people with the name sun, or search a photo, or search group, right? So it gives you image recommendation on Flickr. Next, different classification of recommender system. So recommender system can be content based, collaborative filtering method, and hybrid method. These are the standard method, standard recommendation system. So in content based, it is defining a model based on user item interaction, where user and item representation are given. Explicitly it is given that this user is interacting for this item. Then in collaborative filtering, you have model based and memory based. So here define a model for user item interaction, where user and item representation have to be learned from the interaction matrix. And here define no model for user item interaction and rely on similarity between the users and or items in terms of observed interaction. And when you combine content based and collaborative filtering, it is hybrid methods. This is just for your information. So we'll see again next image recommendation with input as image. So this is now a trending research area, where instead of text you give image, because now everyone has smartphone, and then wherever we'll go, usually we'll have habit of taking photos, right? So rather than the text information, now we have more images or photos in our phone or laptop and all the devices, right? So this is called visual recommendations. So I'll give you one example on Myntra. If you go with the visual image recommendation, then it will ask you to take a photo, and or you can take an image from the gallery, and then based on your input as an image, it gives you recommendation. So here we'll just discuss one paper where it is published by Flipkart. So where you can give image as an input, it uses deep learning, and how it generates the recommendation. So what are the challenges? Because when you give text, actually you are understand the text very well rather than the image, right? Because system need to understand that. So here now what are the challenges? So see, both the shots look same, but here the face of human is there in the one image, while in another image uh, there is no human face. But when you give any of the input, it should understand the both the shots are same, right? So your model should understand these both the shots are same. Similarly, here also it is concept based similarity on the printed t-shirt, right? So that need to be understand. Here stripes. So this thickness of the stripe need to be understood by the system. Then or your model which you develop for image recommendation. Then here you have same top where human face is there, and it is little far, right? It is full image, and in another one it is only top image, but both are same. So your system need to understand that. So they have developed that using deep learning, that is your CNN, right? So now we will talk different recommendation application. Another 5 minutes I'll take, and then I'll stop. So different recommendations application which you will see every day, and we'll discuss about few data set which is available on the Kaggle. So those who want to develop any project, they can use that. So first is movie recommendation based on previously watched movies. So from my Amazon account, I have taken recommended movie. So which type of movie a person is viewing, based on that every time it gives you recommendation. So for to do that, we have here prediction of movie success or flop before its release. So that data set you will get it from the Kaggle. And then you have Netflix data, and you can recommend based on the genre, actor, director, producer, and rating. You can use this as a features or attribute, and you can use other example are Netflix, Prime Video, Adult TV, Hotstar, YouTube. Everywhere you can see the recommendations, right? And then there is one movie lens data set, which in that you have all the movies, almost 45,000 movies with data set like data point as cast, crew, plot, keyword, budget. All these are the attributes. So this is available. So you can use the data set and you can develop your own movie recommendation to understand first that how you can develop movie recommendation, and then you can apply to any of the application, right? Even YouTube videos are available on Kaggle. So that is video title, channel title, publish time, tag, views, likes and dislike, description, common comment, count, all these you can take as a features, and you can recommend the YouTube video to the user. Then Netflix movies are also available, data set of Netflix movie. So that and there here you will have TV show also. So you can take the data set and you can develop movie recommendation system. Then music recommendations, right? So music recommendation can be based on genre, singer, instruments. So Wink Music is there, JioSaavn, Spotify, SoundCloud. So these are the available app where movie recommendation is already present, right? So now if you want to develop your own system, then you can get the data set from the Kaggle, where it is Spotify music genre list is given. Then Indian film music also it is given here, where all the Kishore Kumar songs are available on this, right? And we can use this data set and you can develop a music recommender system. So here you can see based on how it is used, music recommendations. So recommended for you. So if I have played once some Aarti, then it is recommending me or the Aarti, right? So that is how it recommends. Next is news recommendation. So this news recommendation is again text, right? News is in terms of the text. So you will read the news from the Google News, right? And then next time when you will go to Google, it will give you whatever news you are keep on reading every day. Based on that, it gives you recommendation. So here it is Google News, and you can even use this news recommendation method, whatever is on article search also. So if you want to search any article based on IEEE or Springer or Elsevier, then it gives you recommendation quickly, right? So we can explore this. So here to develop this news recommendation, we required user browser history. That means that any user first logging it to which website, from that website which link he'll click, and he will go to the which website or web page, and how much time that he spends on that web page. That means if he spend more time, what is it meaning? That he is reading that news, right? So based on that, this type of information, we can develop news recommendation system. So I will show you over on my phone. Every day now we have habit of reading for COVID, so it article for you. So every day when I open google.com on my mobile, this data, these two article comes. I mean, COVID will come every day. Then based on my search history, it will give me the second article. So this is news recommendation. So you can develop one app also, where from the Google you can collect and you can give me, see, you can combine here now. You can recommend me the news, and even you can give me summary out of that news, right? So you can combine 2-3 application and you can come up with your own application for as a product, right? So next is Trivago. See here, if I'll tell our recommendation, so if I'll be not knowing anything how to use this website, then it is giving me that our recommendation is based on rating and recommended, price and recommended, rating only, price only, right? So you can select out of this, and if you know, you can give here the query, correct? But if you don't know the query, it even gives you the recommendation of the query, which you can select and you can search. So here I will show you one trip advisor search, location based search. So here where to go, so I just told nearby, so it picked my location. So I am from Bangalore, it picked that I am from Bangalore, and then explore nearby places. So when I have taken this, I was sitting at my home. So all these restaurants are near to my home, and then nearby land landmarks, then plan for today. So you can go visit these places, top restaurants in Bangalore. It gives me all the information. I have not searched anything. It gives me all the information near to based on my location, right? So it identifies that where I am from, which place, and based on that it identifies location and give me the search. Then I spoke about the TripAdvisor. So how we can use now TripAdvisor? Many people will go and visit, and then the data is collected, right? So many those who are using TripAdvisor, and then they will upload their photo that they have visited these places. So how that photos can be used for further recommendations. So here one paper is from IEEE transaction on multimedia. It is trip outfit advisor, location oriented clothing. So every time when you have to go for trip, it is like common problem, which cloth I should take or I should go and purchase. Instead of that, now you can develop one system which tells you that go purchase this cloth, or if you have, you just pack this many clothes and go, right? So here this paper tells about how you can use the CNN and SVM, and how you can identify the need for the trip, right? And then they have this can be expected output, that if you are going to some place where it is like history kind of culture or heritage, then you can get this type of cloth. If you are going in some snowy place, then you have to get all the jackets and all. And then if you are going on beach, you can take cloth accordingly, right? So next, now what is the research issue in recommender systems? So first is scalability, because you have huge amount of data. So how you will handle that? Then next is user preferences. So today I'm searching something, tomorrow I'll change some other search, right? So the model should understand the user preference over the time, right? That is important. And then once the knowledge is for recommendation has been extracted, there are still concerns like how frequently recommendation should be generated, right? Because every day you will get the data, every seconds the data are added. So how frequently you should change your model, or you should run the model, right? So that is again very challenging issue in recommender system. Then handling heterogeneity of the data obtained across the multiple users, and also the efficient computation of semantic similarity are the key challenges. Because telling, if we will read the sentence or if we will visually see, it is easy to identify as a human, but that semantic information, semantic similarity should be identified by the model, your model. So that is a challenging task. Balancing the model complexity and scalability with the exponential growth of parameter. So that is one more challenge. So at the end, I will show you that many companies are working on data science and they are posting some problems. So there is one IBM developer website where they will post their own problems, and then you can take participation in that, so to solve that problems. So here it is code patterns. So this is very recent problems they have put on data science. Analyze data patterns to find product insurance claim, then discover hidden Facebook usage, analyze credit risk, then object tracking in video with OpenCV and deep learning. See, this is all recent problems, and this comes under all data science. Data science process pipeline to solve employee attribute. Here it is recommendation system. Here it is text summarization, extract and summarize the text from a travel blog and tweet with the identified, right? So these are the problems given on the IBM website, which you can use and you can solve using data science. Thank you.
Okay, thank you, ma'am. I think there is a query in Q&A box. Can you check, ma'am?
Yeah, I'll just check once. Yeah. Why we are using that video surveillance in data science? See, it is not video surveillance we are using. We are using video as a data. So data science, when you talk, it is a combination of statistics, machine learning, everything that I initially I have told, right? So when you want to identify some event which is occurring in video, then you are giving input as a video, you are analyzing the video, and then you will give the, you are extracting the knowledge, right? So that is how you can say that video surveillance is in data science. Video summarization is little bit confusing. Okay. Okay, I think I have answered. There was 2 questions.
Ma'am, there is one more question, I guess.
I haven't received here.
Yeah, how can we use support vector regression classifier in character and numeral recognition?
Character and
Numeral recognition.
Character and I think next topic is that only. Madam will talk about that. So we can convert that character into a number vector and we can feed it to the system and we can use that.
Thank you, madam. I think that's it. So thank you very much, madam, for such an exemplary session. And I'm sure that the participants have gained knowledge on the applications and scope of data science. I mean, even you have explained about what are the research scope in data science and all the applications you have discussed. So I thank you very much, ma'am, from the bottom of my heart.
Thank you for the
Thank you.
opportunity. Yeah.
Thank you, ma'am. So now we have come to the end of session 2, and we are about to head to session 3. So session 3, we have a guest speaker, Dr. Sahana Gowda. I'm greatly honored to introduce Dr. Sahana Gowda, speaker for session 3. She is professor and head at B&M Institute of Technology. She had received BE in Computer Science and Engineering from Kuampu University and ME in Computer Science and Engineering from Bangalore University. She was awarded PhD degree in Computer Science and Engineering from University of Mysore. She has more than 20 years of experience in teaching in and industry. She has published 26 papers in refereed international journals and conferences. She has received many awards to her credit. She has been working as reviewer for many reputed conferences and journals. Dr. Sahana has received a doctoral committee, has been serving as the doctoral committee member for various engineering colleges, and she is working as thesis evaluator for reputed university in India and Australia. She has served as a member of various academic committees like LIC, BOS, and BOE. Now I welcome Dr. Sahana Gowda to preside over the session.
Thank you, madam. Yeah, good morning.
Yeah. Good morning.
I think we have already heard a wonderful session by Dr. Sejal, and I thank the organizers for giving me this opportunity. And I'm sure this is the situation where we all go online, a big transformation that has been happening in academics. And I'm sure that we all are really being benefited, and we also feel that there is a lot of change in the custom of what we were doing, the teaching learning process, what we have done. But the research also has taken a twist where you could see many people doing online nowadays. So before getting into my presentation, I would like to say that, see, when we say data science, now the buzzwords of technical platform are data science, artificial intelligence, machine intelligence, and all these things. Why exactly are these buzzwords hitting the doors today? One thing we have to understand is that this is because of the voluminous data that is being generated unknowingly as well as knowingly. To customize it for the requirement and the benefit of the society, what we are doing is that we are trying to make the system intelligent. It doesn't mean that the human is becoming lazy. It means to say that the system automatically does it in the place where a human cannot interact, a place where a human cannot take the action as fast as a machine can do it. So technology will never replace a human because it is the human intelligence which has developed the artificial intelligence. So actually, when I say it is data science, artificial intelligence, or machine learning, there are two parts of research which actually takes place. One is how you gather the data, and the second part is how you analyze the data. The factor here is that the researchers just say that I am not going to touch that part. I'll be doing only this part. No. As a researcher, we are supposed to take care to holistically understand what exactly is happening and what is the state of the art today in the area where you're going to dive in. That is very much important. We should never say that I'll just stick on to this. The sticking on part where you say that I'll be doing only so much, that means it is relatively to just to say it is a project or a dissertation. So when I say it is a research, what we have to do, you should know all 360 angles of how you're defining your problem statement. Define the problem statement, but later part of it, how much we are really going to understand what exactly is available, what is the limitation of it, you can set the constraints. Nobody says that you have to do. But only thing is, I think we have to give up saying that this is what I found. No. As per the history says that from past 2 decades, we should go by saying like this. That is where a researcher has to contribute his or her time in understanding what the previous researchers have done through. And also you have to experience the research. It is not the output that really matters. It is how much did you experience the good, the bad, the truth, the false, whatever we do it. So my presentation today concentrates on how exactly the data in one form is being transformed to a big data, and then probably the methods of whatever the data science. And if you think that you are talking at the project level, then we are more interested in knowing about the technology or the technique that we have applied. If you come to a dissertation level, I would just take 4 or 5 papers, compare with each other, and just say, okay, this is the contribution of X, Y, Z, and say this is the efficiency that has come. But if it is a research, I shall try to see that how I extracted the data, what is the techniques that I have gone through, what are the papers that have been implemented, and what is my suggestion towards it, and what is the improvement that it can be done. So this is what is required. Today, my presentation is on document image processing. I think probably this is a very critical area, and most of them never can imagine document can be treated as a data here. So I'll start sharing my slide. I think the slides is visible.
No, ma'am.
No?
No, ma'am. Can you share it once again?
I'll just do that. Now it's visible.
It has not come, ma'am.
I think it'll take time to
Load, yeah.
no?
Yeah, now it is loading. Yeah, it is visible.
Yeah. So my presentation would be on fingerprint generation for document images. So basically what we are trying to tell here is how the document image itself in any part wherever it is being stored is getting converted into a data format. So conversion of an image into a data is also a part of data science. So what are the techniques that we have used? What is the uniqueness that the document is being portrayed and how it is being converted into data is whole of my presentation. So this is basically the first research scholar. Yeah. This was the work carried out by my first research scholar, Dr. Surabhi Narayan, professor in the Department of Computer Science and Engineering, PS University, Bengaluru. And this work was also supported by funding by Vishweshwara Technological University, Belagavi. And the project, which was entitled, was Code Generation for Document Images based on handwritten components. I think the title, and this was in 2011 to 2014, and we had a good fund, and that really supported us to generate data. And also, we had a good support from a research assistant where there was a good work that was contributed here also. So before this thing, let us understand. So document image, when we say it, we all know that documents are hard copy documents. When I say it is a hard copy documents, you have a touch and feel of it. But when I scan it, when I store it, I think you know that there are JPEG formats that are being stored today. We say it becomes an image there. So when it is an image, I think the first thing that comes to your mind is there is something called as an OCR, which starts reading itself. The image becomes a text format, and the text is again converted into a speech format and these things. But in this work, what we are trying to tell is that today, as you see, it is a digital word. We are very scared to touch the document where the other person has handed over to you. So it is a COVID-19 and a pandemic situation where we don't want to pass any object between the persons here. So then what do we do here? So that is the reason we have just started sending the mail, sending the document scanned so that it is easier also. And it is not just today because of the pandemic situation, but from past 20 years, the initial days where Rangachar Kasturi and all started thinking that document is going to be an image one day, probably the offices will be a paperless office. So today, I think that is very much true. But that is there on our table. There are lots of papers, but still we have lots of documents in the computers or in your laptops or in your remote servers, right? And if you could just go through any of your folders where you are preparing your own document, there are versions of documents that are being stored, right? So what is happening to all that? Why is that you have different versions? Probably because that you have made little variation and you're scared that you may lose the previous document, you start doing it. And also sometimes now you have all online applications. You're designing Google Forms. So Google Forms are not actually document images. They are the front end tools, the front end form that has been developed, which automatically generates the Excel, right? But there are some cases where we have scanned the existing document, say, for example, the application form. I think this was the enrollment form that we were using at B&M Institute of Technology. So this enrollment form, if you see here, right, probably when you say, see the things that are handwritten there are the important or the vital information that makes the two enrollment forms different. Other than that, whatever the table that is there, the BNMIT, all the name, USN, semester, residential address, all these are the common entities that are present in the document image. So when we see that, what really is important here? Is it the application form which is really mattering, making the two enrollment forms different, or is it the vital or the personal information of the person that is being put on the application that it is making vital? So what we contribute here is that how do you say that looking at the vital information that the two enrollment forms are different? So can you generate a unique fingerprint? I think we are very much used to, because most of us are in this academics from past 10 to 12 years. If you have gone for valuation, every answer script is being coded manually, right? The person in the clerical job, he just rolls on the USN of the students, pins it, gives a unique number with taking many entities into consideration, something like a college name, the USN, all these factors. But is that possible based on the vital information you auto-generate? Can a machine auto-generate a unique code? And that unique code should be identical for the same document if you try to put it. So how can we do that? That is what is the problem statement here. So what I can show is the various kinds of documents. So that was an enrollment form. The second one is the report card. We used to call it as progress card. And especially another application of it is the check leaf, right? Normally what we do is we write the check leaf and we present it to the bank. So bank people, if they could scan it and auto identify the vital components, and with that unique code that is given to this checklist based on the account number, can it automatically deposit the money into that account number? So these are the kinds of application which really matter. See, these are some of the railway reservation form. This was so challenging, especially in India, where there is multilingual languages that we have been talking. If you're in Karnataka, a railway reservation form will have the same text in Kannada, English, and Hindi. Same thing if I go to Tamil Nadu, it's going to be Tamil, Kannada, I'm sorry, English, and Hindi. So like this, there are so many challenging applications. So what really matters? Is it the application form which matters, or the data that is filled by the user which really makes the application different? It is actually the data that is filled by the user that makes it different. So when I look at this, let me say this is a form. Again, I've come back to the same form which I showed in the first picture. So basically, when you see that, what do we see here is that this is a filled in application form, right? So then when I just see here, see the username. So that is the username, USN number, the signature, and right, the signature of the student. The more important ones is that these four. So the name, if there is a repetition also, university will never give a USN number same as to the same student. So coming to the check leaf again. So check leaf also, you can see here, there are so many things that are filled by the user. They are all handwritten here. Sometimes there could also be typed, or there are printed text also, which is a unique entity that is filled on the any form or on a checkbook that has been done, right? So I'm just showing you all these, the kinds of examples that we can consider to solve, which the problem which we have considered can be solved here. So basically, you can see here. So what is the present situation? What is happening? So the remote server contains all these documents as images itself. So it is physically storing. Let me say that if a document is scanned, if it is taking 100 MB of data, this data is stored remotely everywhere. Probably they use some compression techniques to store it. Fine. After they store it, when they're retrieving it, they're retrieving the image, just not storing it. Look at the the bandwidth that utilizes in the transmission of sending it and retrieving the document image, right? And the local machines that retrieves these ones, right, based on the requirement. So what would I have done? I would have tagged it with one unique code, irrespective of whatever it is. And that unique code, I had to maintain it in one Excel sheet. So whenever I want this document to be retrieved, I give that unique code to it. So we have something called something like a barcode. So barcodes are not really portraying anything about the document. Based on their occurrence, they just change the sequence number and barcodes are getting generated. So, but what is happening? This same document, if it occurs again, another barcode is generated. So, excuse me, this is how the document is being indexed today. So basically, what is needed? So we know that on retrieval of such documents, there is a possibility that the same document would have been stored using different barcodes here. To overcome this, so is there a possibility that I have a remote server which is storing one place the images, and in another process which can generate the fingerprints for these document images and just circulate these fingerprints wherever they are required, and then whenever you want it, you just type these fingerprints and you can get those documents. I think this reminds you of the digilockers that have been designed today, and today government has already implemented those digilockers. I think you'll have been using it today. The 10th standard mass cards, the second PUC grade sheets, and all these things, you don't have to. Even the medical report, healthcare has improved so much that the patient details are being stored in the digilockers. But only thing is the heterogeneity, like, there is a government, let's say Tamil Nadu or Karnataka government, the state board, they have their own ways of formatting the mascots. They don't have the same format everywhere. So that is the one which is really making it much more complex. Whatever could be the format, depending on the vital data, can we generate a fingerprint is the problem statement here. So that is what I was trying to tell. So can we generate a fingerprint uniquely for a document image based on the vital information that are available? So generation of fingerprint is based on the vital information is the need of the time. So what is the vital information? As I've told you, it is already the personal information that is posted or printed on the application form, right? So how do you do it? So basically we cannot, as we told, as I already told, it is a multilingual nature, especially in India, any country for that matter. There is no country which says there's only one language. It is a region based context documents that are floating around here. So what do we do here is that, do you think that you should develop an NLP where it should become a machine intelligent that it will recognize the language and start reading it? Is there a possibility without reading it, based on the structure, that we start organizing the document and generate a unique code for it? Yes, because see, the structure of ABC, we start labeling it when we start from our kindergarten, right? We write the structure and say it is A. So we have labeled a structure. Rather than taking label into consideration, can we just use the structure to compare the two document images? When we do that, that will become a multilingual free of it. You don't have to worry which document is it. And also, when there is a structure that is occurring, the position, I think you have already seen, some of the applications could be portrait, some of the landscape. It all depends upon the designer and the one who approves it. Nobody is worried about the placement of it. But when I look at the two documents for a language which I don't know, I start structurally matching them. Can your machine intelligently develop such a code without knowing the language, keeping the language into context, say that, yes, this is the unique code of the document, irrespective of the language? So that kind of a model will really have a good benefit for the society, so that you don't have to worry about any language you document, you can give, automatically it generates a unique code. So that was the research problem that was defined by my first student, Dr. Surabhi Narayan. So we're getting into it. So how the document images are generated locally, as well as they are being put into the repositories, and the way they are being retrieved here. So what we did was, actually when she started the research, we were not getting a standard data set. For document images, the standard data set is basically approved by ICDR or IJDR. These are the two conferences. ICDR is a conference, IJDR is a journal, where they are the high rated conference and the journal which really the researchers who are working on document images should publish their work on. And there are some approved data sets by them where they have used it for some of the competitions, some of the techniques that have been proposed. But basically, the kind of data set that we wanted were not available. And we had to approach the university. The university supported us because it was a funded project. We could get some data sets from there. And also, we generated our own data sets and we created a repository. So there was 400 students enrollment forms, 400 application forms, 200 checks, and 100 declaration forms. So when you see all these things, there is some connectivity between all of them, because the uniqueness, the signature of the person is there, the name of the person is there, the photo is there, all these things. So I'll just go by. See, one is the application form, another one is a check leaf, which I shall just be declaration form, registration form, all these things what we have considered. So when I just see how we have interpreted a document image now. So a document image, as of what we have interpreted, has three layers basically. I say one is a background. So before printing anything on a document, which is an empty white sheet, which we call it as a background, right? So once we have a empty white sheet, I just print on it and make it an application form. So now you see this is an application form. So this, I just say, I cannot tag it as it is somebody's application form. I can just say it is the application form of BNMIT. So all the students of BNMIT will use this application form here. That is the foreground. The empty white sheet is the background. The imposed, I mean to say the foreground, that is the application form, the general data that has been printed on it. Now, when I fill it, that layer becomes the imposed layer. So this is how we have interpreted the background, foreground, and the imposed layer. The challenges: how do you separate all three of them? Take out the foreground, take out the first you have to take out the imposed layer, next the foreground, and then it becomes the empty background. So what are the various techniques that are being used? Actually, we have also evolved with new techniques, right, to come up with how to extract this, how to generate a unique code here. So basically, what are the things that has been proposed in this research work is that extraction of vital information. See, this is the vital information what we consider like. It has foreground as well as the imposed layer. I think now it is very clear. Whenever I refer to background, it is an empty white paper. Whenever I say it is a background, it is nothing but the empty application form with general information. And when I say imposed layer, it is the filled in application form with vital information in it, right? So now, which you saw that I just lost it. I'll just go back to say that this is what? This is an application form which has been taken as an input here. So when the technique, like when I use a technique, I just remove the application form details here and only the vital informations are remaining. And I further process these vital information into something to generate their locations, the centroids of those components which are being remaining. I shall go in detail in making you understand that how we have converted the document image into a code that is nothing but a binary code that has been generated here. So, right. So this is, and then this is the code generation. I shall go in detail, and this is how the code is available. So there is two types of codes. One is the layout code and the structural code also, which is getting generated here. So combining these things, we have generated unique code for a document image, right? So to extract the vital information, fine. Now, as I told you, the vital information is in the imposed layer. So just I want, and the more concentration is on the imposed layer. And I'm sure when we generate a repository of the application forms, I don't generate an enrollment form and a check together. And I make sure that now when you share a Google Drive for the document for the students to put their answers into, would you think that all the 6 subjects would have been dumped into one Google Drive? Or would you think that every teacher would have used the same Google Drive? We would be smart enough in saying that every subject Google Drive is explicit. Just put into the same subject code with that into a single Google Drive there. So similarly, our assumption is that the cluster of document images which are considered for the generation of fingerprint are unique in their nature and are the same application forms. If it is students enrollment form, all of them are student enrollment forms. And if it is check in the bank, it is check in the bank. Or it could be application for bank account openings, which you have submitted to the bank. So we make sure that the cluster of documents is the same here, right? So what happens here is sometimes, let's say, I have generated a cluster of documents where there are application forms, and tomorrow I say that I don't have a template only, right? If I have a template, I think most of you all are very much aware, they just directly do is that just do a subtraction. So whatever is there in the template and whatever is there in the filled in document, the separation will only give you directly the imposed layer. But the problem here is that today we have transformed ourselves to say it is all digitalized. But earlier in the conventional system, now also the university has asked for take the printout, sign it, scan it, and send it back, right? When they have signed and scanned, look at the complexity, it is increasing. There is a possibility that it could have got tilted. There is a dust introduced on it, and their clarity would have been lost, right? But at the same time, I just want to also note that whether it is possible for me with all this complexity to just extract the vital information. So the extraction of vital information, two methods have been proposed in the presence of the template. In the sense, I have an empty application form and I have filled application forms. I just register them and I get the vital information. And also we have done another method in the absence of the template. Let's say that we don't have a template at all, like we have just a filled in application. How do you say that these, the only point is that they are all handwritten documents. Assumption is that your applications form is being handwritten. That is the imposed layer as handwritten components in them. So we should look at both the methods in the presence of the template and in the absence of the template also. So first thing is the presence of the template. So we call this as document image registration. So when they say it is the image registration, the template and the input will be aligned one on the other, right? But do you think that alignment is such an easy process? No, you are not just taking out and putting it. When I see that the scanning, I would have scanned it in a different resolution. I would have scanned it little bit of tilting. All these things, geometrical variations really cut down the efficiency of the model here. So overcoming these geometrical variations also, we have reached a very high accuracy here. So one you can see is an empty template, another one you can see is a fill template. I shall avoid getting into mathematical modeling the way we have done it. I shall just portray the results, how we have achieved it, and we can see that. And I'll just mention the techniques that have been used here. So as I told you, these are the geometrical variation. Let's say the first image is so clear, but still it has lots of noise. The color itself is so much variant. But when I take the input image, which you can see to the right side of the template, you can see there is a lot of tilt. So when I just automatically just crop the information, and if I just try to put one over the other and subtract it, I'm sure I will never get the vital information. There could be some cuts in the information or something would have been lost also. So the geometrical distortions that have been considered are translation, rotation, and scaling. All the three have. Translation is that we would have reversed it, right? Rotation, there is a tilt in it. And the scaling, there could be little bit of enlargement in the input image when I would have scanned to the original template, which I have it here. So basically, these are considered for image registration. I'll just go with one line. So we just find out the outer key points. I'll just show you how the output looks here. So using the convex polygon, we have generated the key points, the most exterior points for the template as well as for the input image. Then the transformation estimation, the rotation is in the range of 30 to plus 30 to minus 30 degree. Scaling is 0.9 to 1.1, and these are the limitations. I defined the problem saying that these will be doing it. That doesn't mean how much is the variation. Do you think all possible variation works out? So we have limited. These variations can be, and I'm 100% sure we'll not be very careless in saying that it will be tilted 180 degree. So when we do it carefully, but as you know that when we scan it, due to air pressure, when I close the lid of the scanner, due to the air percolation into it, there could be a little shift in the image and the image would have got tilted. And such conditions are the only ones which we have to consider. Today, I think you know that scanners, you just feed it as an input also. They're not like the earlier days where you used to keep the sheet and close the lid, right? So it is still better. So working for 180 degree rotation is not worth today. So you know that the minimal tweaking of the input image will give you a better results. So we should also make sure that what is the problem that is existing in the technology today, rather than thinking that I shall solve this problem and start from the beginning. You don't have to solve the problems that has been already solved. Try to renovate it with the better, either improve the efficiency, either improve its, the constraints, release some of the constraints. Now we have said the scaling is 0.9 to 1.1. If you want, you can make it more. Can I compare a day where A3 size and an A4 size can be compared? I think probably there's a limitation in this method, which somebody really wants to take up that as a research, you can do it. And because this work has been completed in 2017, I won't be surprised if you see the work which has already come up to say how to compare without reading an A3 and A4 and say how much equivalent they are. So that is what it is. You should, when you're reading, we should make sure that we understand what is this problem still existing? What are the constraints that they have laid to solve this problem? Can I release one or two constraints of them and innovate new things for the betterment of the society? As a researcher, our problem is that you solve the problem and leave it. As an entrepreneur, he picks up the problem that is solved and brings it to a prototype and makes it to a product, right? So there is a lot of variation when I'm doing a research, when I'm doing a product. Product really doesn't require research, but research really requires a detailed survey. I think you have heard about Dr. Sejal. She was talking about how surveys were so much important, right? And surveying, it doesn't mean that you're finding a solution in a paper. You're trying to understand what a researcher is trying to convey from his experience. That is what you have to understand here, right? So then what we do here is we start solving a problem. As I've already told you, the limitation of the proposed method, what we have done is the rotation range, scaling, and the translation that we have considered. Yes, somebody can pick up it saying that let's assume there's a vast, if there is a requirement in the society, just not assume it, what is happening. So go through what are the types of scanners professionally they are available today. So what is the problem if those kinds of scanners outputs are available for me to do the registration process? Then take it up as a problem, right? Transformation of the input image. So we have transformed the complete input image into a data. It is not the just final binary data. Initially, only the images are being considered. From the second stage onwards, it becomes the mathematical modeling on the variable data that we have considered here. Then we have done a connected component analysis. Then the elimination of, sometimes what happens, as I've told you, when we did registration, we could not achieve 100% overlapping of input and the template. There was a the misvariation on overlapping, where there could be some residues that are left out, that could be the common components but not the vital components. Then what did we do was we did something, some elimination, assuming that those locations were also present in the template, and we removed them also. This was a very beautiful work just to extract the vital information, that is the information imposed by the user onto the application form. So I'll just go with the outputs. As I told you, this is the convex polygon around the template. And you can see that the quality of the images are so low because we made it a point that we generate these documents, keep it aside for 6 to 8 months, and then I start scanning, because today you have seen there is a Boomi software which has come out where it says that all your papers, legal papers of your property need to be scanned and put into it. Do you think the quality will be as fresh as a new paper? No. That would be a paper which would have been generated 3 decades, 4 decades. The paper would have turned yellowish, and the more vital information would have lost its clarity. And that situation also, can you say that these two are same documents and generate the unique code, was the challenge of this problem. So we have generated, you can see the convex hull, that is polygon that has been fit. So from this polygon that has been fit, we have taken the corners as the key points. I said initially we extract the key points, and keeping those key points has been plotted on the same graph, and this is what we get on the borders. And when we get it, we have used the geometrical transformation, which I've told that the consideration. Can you see here? There is not much variation here, which we can observe. So these variations can be easily made up. And the point is also, I am very careful when I'm scanning the documents. I'll never be very careless in doing such things. I mean, it's everybody does the same thing. It's just not me. Because it's a document, an important document that is going through it. A student application form, student's mask card, it could be a property document, it could be a legal document, a court document, anything, a healthcare document for that matter, right? Anything for that matter, we would have been taken care. But still, because of the limitation of the system, there could be some geometrical variation between the template and the input image. That is the reason we have gone for image registration here. So then when we have done this, then ultimately when we subtract it, you can see here, what we have got is only the vital information that is being stored, or that is being written by the student. And that is what is extracted. This is the extracted, and we have put a very good image. We have seen the worst images also, where there were a lot of common components left out. That was the limitation of our method, probably. And then that is the reason we went into identifying these common components and eliminating them also, right? So then these two, those I've just given some more examples to it, and these two were again the application form, and one is the fill form that we had considered here, and this is the convex hull that got generated, and one is getting imposed. The first one on the left side, it is our inputs that we had considered, and after geometrical transformation, that is what we get it here. You can see very closer overlap, but 100% overlap is not possible, because as you know, if you just try to map the jigs puzzle or whatever it is, they look closer but they cannot be mapped, right? Exactly, one can be the identical for them to map on one another, but here it's only the similarity factor. There's a lot of difference between identical and similar. They are not two same words. Identical is exact replica. Similarity is commonality among the two entities. It's not one entity here. In similarity, it is two entities, and in identical, it is one entity, its replica, which is present there, right? So in this case, because it is two separate entities, that overlapping even after registration, which you can see is not 100% here, right? So this is a filled in. I've just shown some of the examples that we were outputs that we had got it here. So this is all for various kinds of application forms with the template and the input images that we have considered. So this is also one of its kind. Here, this was also, you can see. Yeah, and ultimately, got it, the ultimately extracted components of the imposed layer is very less in this case, right? But also you can see some of the noises that is still left out in the extracted imposed layer also. So the next one is discrimination. Why we went to this discrimination of handwritten and machine printed text in scanned document images, that our assumption here is that all the applications, because they are scanned document images. When I say why are they being scanned, because the application is filled with handwriting, and then it is being scanned, and then it is being transformed into the repository or stored into the repository. So this method was proposed where the template, let's say, why would we store an empty template along with the filled in applications? End of the day, after 3 years, when I go to open, I don't have a template at all. I just have filled in application forms. So we thought was that let's just identify machine printed text and handwritten text in them, so that the handwritten texts are the only ones which will be the vital components which will be there in the imposed layer. So we started doing that. One thing, when you just look into it, uniformity. When in a printed text, their characters are all uniform, right? But whereas in a handwritten text, they are non-uniform in structure. Structures looks similar, but they are not identical in handwritten. But structures are identical in printed here. So what we did was we separated, we applied a segmentation technique at word level, and document was segmented into words, the sequence of words. So how did we do was that, like, we could know the space between the two words. So initially it was paragraph, then it is line, then it is between the words. The spacing which we considered was that sometimes when it was a handwritten, we are sure when we are filling it, there may be a possibility we overwrite on the printed text, or we connect two words and write it. All these things are also considered here, right? But how did we do that? The transitions are used to depict. Transition is nothing but, as we know that the document is a black and white, the imposed layer is always in a contrast color to the background, right? The document image has a white background and the content on it is a black color here. So when I take this document image into a algorithmic format, where I find is a value that is representing black and a value to represent white. I think it is a binary format, which all of you are aware about. So what happens here is, it was very clear that one was white and 0 was black. Wherever there was a transition, when I do a run length smearing algorithm, I think all of you are very much aware about it. where the whole document image becomes a matrix of size m cross n. When I scan through row wise, what I understand is that until it is a white pixel, there's going to be a sequence of ones, and automatically next one is going to be zero when it encounters a black pixels. Whenever I encounter a black pixels, it is because of the imposition of the structure character on the white background, right? Considering this as the information that it makes the difference between the background and the foreground, we went into considering the transition as positive. Positive is when it moves from 0 to 1, and it is negative when it moves from 1 to 0. So we call it as transitions, positive transition and negative transitions here. So I'll just give you the critical lines that we define. Normally, this is not the research from today where we are defining the critical lines. This is there from past 2 decades where people have said that the structure makes it to define 3 lines basically. Actually, we defined what is called as the baseline here. So there we have named it, which you can see a top line. X line was named by us, baseline was named by us, bottom line. Lots of research have been done by people to find out the structure of the word or the line without the context of the language, right? Or without the label part of the structural part of the characters. So with that, we could define it. I think in the matrix, this is what I was talking. The word which we have used is lap, and you can see the equivalent binary matrix of lap there. It builds it into rows and columns, right? And wherever there is a transition, the top line transition you can see, the X line transition you can see, the baseline transition you can see, bottom line transitions also you can see. So we applied a logic where it exactly defines these lines for a word here. And that was also very true that for a printed text, it was very uniform. For handwritten text, that uniformity was missing. So encashing the uniformity characteristics of the components of handwritten and printed, we propose the model here, right? So these are the rules. First method that we defined was the rule-based engine that we consider. So if a word has been passed through this rule-based engine, then it would classify it as as handwritten, or it is a printed character, printed word basically. So then later, this you can see here. See the lines that the way discrimination of handwritten and machine printed. So, and also the distance among the lines that was very uniform in case of printed text, whereas in handwritten that was getting lost. So that majorly was the difference that we could find out, that this is an handwritten and this is a printed text here. Right. But what was happening, that was like actually we were trying to figure out the distance between the number of lines. The limitation of that method was that we every time had to consider the size of the matrix, and then we had to find out. So to overcome the limitations of the previous method, we have got rough set into this document image data analysis. So rough set theory, I think all of you know it. The way we have used it to build the knowledge of uniformity among the characters in the word. So this is the equivalence relation that defines the rough set, and the derived rough set word components are identified as either machine printed or handwritten text here. So I'll not get into how technically we defined it. It is again a rough set on the transition. As I've already told, transition is from a black pixel to white, white pixel to black. So where we have said that using this, when we do it, we could identify the machine printed and handwritten text. I think you can go through the paper that we have published, that has been published in WICT 2012, the discrimination of handwritten and machine printed text and scanned document images based on rough set theory, where you can see the complete mathematical model that we have explained there, and you can use it also. And see, what I'm trying to tell you is how we can relate maths. Basically, when we say we are computer science engineers, we are talking mathematicians, the formulation, the application of the maths for the analysis or the outcome, that is what is required here. So we have got rough set to identify or discriminate the handwritten and the printed text. I'll not go much into it. So we have understood that we were just talking about the text as handwritten and the printed text. getting into document layout analysis was also a matter, because layout also contributes in saying that these are the documents which belongs to a cluster. So we did as document structure analysis and document layout analysis. In layout analysis, basically there are two types: geometrical layout analysis, logical layout analysis. Geometrical layout analysis just tells us the position of the components in the document image, whereas the logical layout analysis tells us the adjacency relationship. Let me say there are 10 components. Let's say who is the neighbor of whom, where is it, where is the location placed, how far is it. This is the logical relationship. The position of them is the geometrical layout analysis. I think these are all very old, defined in Rangachar Kasturi, which was the first document that was generated to give clear idea to the researchers on how to treat a document as an image. So in the logical layout analysis, we gave a layout structure to the imposed layer, because we knew application layer, I mean the application form, background, foreground has a clear layout, but the layout entity would have been lost in the imposed layer. So that is why we defined it that you can define the layout based on the occurrence of the component of the imposed layer here. So for doing that, and basically I'll just get into how it was being done. Every component after extracting the imposed layer was bounded by the box, and we find it the centroid for the components there. And what we did was the complete document was divided into 4 quadrants at the first level, and then divided the further 4 quadrants into next 4 quadrants at the second level. We call it as 2 hierarchical quadrants. And so we had around 16 equal quadrants for it, right? Quadrants are coded from right to left, top to bottom. So we numbered even the quadrants also. Why? Because we did not know explicitly this would be the location. Depending on the handwritten, the way you write it, that was the place that was occupied by these components. So that's the reason what we did was we made it that wherever they may appear within the box that we have mentioned, we wanted, because we had to convert again the position into binary codes here. So that is the reason we divided the whole document of the imposed layer into what are called as quadrants here. I think you know Huffman tree also. And we have used Huffman tree to generate the code and the graph for the quadrants that we had generated here. I shall pictorially show that also. Yeah, this is what I was talking about. On the left side, it is the document image that is divided into 4 quadrants. And then every, let's say, and it is being labeled anti-clockwise, if you could see, Q1, Q2, Q3, Q4. And every quadrant was further divided into 4 more. So that is the second level of hierarchy. The first level has 4, and the second level, each quadrant is divided into 4. So 4 into 4, it becomes 16 quadrants together. So, but that 16 quadrant was mattering because in the first quadrant, it is such a big quadrant that again, it could be on the top right corner or it could be on the bottom left corner. Will it be the same? No. So if you think that the complexity is much more higher, you can take it to the third or the fourth level. So that is still in scope for the research to be continued here. But Surabhi has stopped it at second level because there was not much components in the imposed layer. And one more was that because we were always taking an application form which is being filled. We have never taken a newsletter, right? We have never taken a story letter, whatever it could be for that matter. We have taken the data which is an application form. So we specifically know where exactly the imposed components would be lying in the document image. So this was much more enough. And as you know, when you get into a micro level, the complexity also increases here, right? Then each quadrant was labeled here, and every quadrant was numerically numerically defined here. I think if you have all done logic design, you have seen what is known as corners map, right? Corners map was the idea which we picked up to say that let's number the quadrant here. So that is how we had got the numbers. Why are we numbering here? The centroid of the component, if it lies in that particular quadrant, that would be the binary code of that particular component there. So that is why we had to number these quadrants also, right? So let's say this is the application form. This is the application form which I have taken. You can see there are two images. So first one is I have just divided into first level of quadrants. There are only 4 quadrants on the left image. And when I come to the right image, those 4 quadrants are further divided into sub 4 quadrants, which becomes 16 quadrants in this image also. And look at the components of the imposed layer. Now what we do is we put a bounding box to these components, and which you can see the blue stars there. It is nothing but the centroid of those components. So that centroids are the indication where it says into which quadrant do they lie there. So you can see that we have taken that quadrant, and I'm using a 16 quadrant. I don't show it. I've showed there for 4 quadrant. Here I'm showing it for 16 quadrant. And depending upon how many components are there in each quadrant is those numbers 1, 0, 0. There is again a limitation here. You can see some of the dots are on the lines. That is unsolved. We have assumed that it will be into the lower next box which we have considered, where you can use fuzzy logic to resolve this problem. So there is a scope for improvement of research here again in this problem what we have solved here, right? So the numbers which we have got, we have used Huffman code. I think you know what is the technique of Huffman code. Huffman code sorts it from the orders from smaller number to a bigger number and develops the tree in which order? In a bottom up approach, it develops a tree, is it not? So you can see that every node has a quadrant number, right? And the lower quadrant numbers are emphasized. They are telling you that those are the number of centroids of the components present in that quadrant. So quadrant 22 has 1 centroid, quadrant 14 has 2 centroids, quadrant 33 has 2 centroids, and quadrant 42 has 2 centroids. So as it goes, it is just the addition that we have done for the intermediate nodes to get generated. So it is 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 4 is 7. We don't give the number as it goes to hierarchy. Then the tree is being constructed here, right? From that Huffman code, Q14, let's say, if you take it from Q14, it goes 2 to 3. So that is 1, 0. 3 to 7 is 0. 7 to 14 is 0. 14 to 23 is 1. So that's the reason it is 1, 0, 0, 1. If you take a Q31, it is 0, 0, right? So that is how the code is being generated for the application form based on the location. So assimilation of quadrant codes and Huffman code. So what do we get is this is a very big code that we are getting into it, right? And then the code for the logical layout of the application from the image that we have considered also here, right? So spatial occurrence of component centroids in the check. This is another example that we have shown you for the check also. The top pictures show that we have extracted the imposed layer, and for that imposed layer, we have constructed the connected component box, and for each box we have extracted the centroid, and the centroids are plotted on the quadrant box, and then we number the number of centroids within each quadrant box here, and then we construct the Huffman tree. So then our Huffman tree is traced to get the logical code of the Huffman tree, whatever we have got it. So this is for the student enrollment form. I've just shown many applications here that we have considered. This is what we get after we convert the imposed layer components into centroids and put them onto the quadrant box. And these are the numbers that it has. That is the number of components. And this is the Huffman code for it. I've just showed it on different inputs that we have considered, right? And this is the final code for the logical layout. And then this is again another kind of a form. You can see here the imposed layer has very sparse components. Hardly there are only 1, 2, 3, and 4 components that are available. Do you think at this point you need to go to second hierarchical level, third hierarchical level of quadrants? I don't think so. But the point is, how big is the document image is again a limitations of this method here. So this is what we have shown for the quadrant numbers that it is generating. This is the logical layout finally from the Huffman tree again. For every quadrant matrix that we have constructed, Huffman-Tree automatically gets generated here, right? And then once we have done it, there is again one more limitation that we came across, what we understood, as I told you. It's just every word component has a unique structure because they're all handwritten. Because it is handwritten, you may, because you know it very well. Let me say that I have been sent to some Portugal country and a document is given me for two documents are given and I have to compare both of them. What would be my client? I would just go by structures, right? I would never know how to read and tell their equivalence there. Then automatically I start comparing the structure. And for me, if there are two A's written by handwritten, I'm sure I'll say they two are different. But if it is a printed A, probably there will be a size variation, or it could be an italic or whatever it is, but still I say the structure is same. But in a handwritten, it is very complex to say that this is the exact structure of A and label it also, because we are used to knowing what are the ways that humans are writing A, that we are trying to tell, okay, all ways you write it, I know this is A. But if I'm unaware about it, I start really analyzing the structure without the label to it here. So that is why we say that the handwritten word components are highly dynamic in nature. So variation is one zone and writing is what we have been analyzing. So you should have a very good supervised knowledge to do that. So that is why we went into component analysis, structure analysis for handwritten components. Here, and this is a very beautiful work where we have generated fingerprint for the text components. Actually, when you saw that the logical layout, I was losing the complete structure of the component. I was just replacing the complete component by the centroid there, right? Probably if there are two similar words of very closer structure, this centroid position could be the same, is it not? Again, centroid is not based on the only geometry, it is based on the density, that is the total number of black pixels within that we had considered also here. So to overcome that limitation, we said let's do a structural analysis on the components based on the locations. I never compared a component which was the first component to the 10th component. We just compared the first component to the first component. As I've already told, the assumption is that the documents that are considered for comparison all are on the same application form that we have considered. So this is like based on the structure, the upper and the lower profile and the gradient computation. Again, I should not get into much of maths, but you can also refer to the paper on fingerprint generation for text components based on entropy that we have considered. I think entropy is not really a new word. I think everybody, all of us as image processing and pattern recognition people know what is entropy, right? It's in the International Journal of Image Processing and Visual Communication. I think this was published and we have missed the year. It is in 2017. So with that, I'll just go into the details. Like we have extracted the key points based on the gradient dispersion. So pre, crest, and corner points were extracted, giving the 2 points x1 and x2. The gradient is defined as y2 minus y1 by x2 minus x1, what we had considered. And this was the location. I mean, we tried to see the peak variation between the two gradient variations that we considered here, right? I'll just show some of the examples. I think probably I can take another 10 minutes. This is the degree of variations that we considered for it. And generate the contour profile, compute the gradient of dispersion, retain the peak, crest, and the corner points, recompute the gradient to extract key points from it, and then the angle of deviation between the successive key points. This was a very beautiful work where we tried to say that the structural variation, that because it is a handwritten component, and it is so unique for an individual that he himself cannot write the same way the way he or she has written previously. That's the challenge today because signature verification is still a problem. I think now also after 10 years or 5 years, bank has a rule that you have to go sign it once again because your own handwriting variations would be so much age-wise, year-wise, and all these factors come into account. So what we did was it is only on the nature of the structure that floats onto the writing that has been considered, and this is a very good work that we had a publication in IJDR also here. So these are the word component, contour profile, the way we have picked it, the gradient dispersion. The first, the left side, that is the input, the word component. Then we take the contour profile of the word component. From that contour profile, we take the gradient dispersion. Because the gradient, I think you know what is a gradient. It is a tangent that goes exactly perpendicular proportion to the actual nature of the curve that it is considering. So that is the gradient dispersion. And because it is handwritten, you can see lots of gradient dispersions are happening wherever there is a change in the curve there. So we've thought that we can reduce those number. Among them, we have picked up one point closer to them, and we have called it as key points here. And from that key points, we have generated what the code here, and that we call it as a content code. Content code is based on the word structure which we have done. We don't know what is the real word reading. We are not going by reading and understanding whether it is Arvind Ramesh. Because I'm able to write, I'm doing. Tomorrow you give me a structure, it automatically gives. The assumption is that it is a language interpreted script that we consider for reading. That's all. But here we are not reading any of it here. So that's the reason. And that's the way that the documents, this is for another word that we have considered. And I've just put few of the examples that we have considered here, right? So you can see, and printed word. Now what you have understood is that we have three types of codes that are basically generated. One is for the layout of the imposed layer, right? And one is for the component boundary box that has been generated. And the second one is the content, the structural of the script that has been written by the human, right? So for all considering all this, we had to assimilate all these codes. Actually, we just brought it to a very huge binary code and we have left it. The scope for improvement is if you could work on that code alone and condense it to a 12-bit code or a 24-bit code or 32-bit code, it's really a research work. They are happening. But I think all your code generation techniques can be used, but only thing is it should not what to say, it should not lose its uniqueness. It should make sure that it retains the uniqueness when it is concising the code here, but which we could not do it. So that is the major limitation of this work, that we have just converted a document image into a set of binary code that we have generated for. So that if you compare bit to bit, you can see that you can find out the variations, and you can also tell where is the variation, whether it is structurally varying, whether it is layout wise varying. Also you can find out the variations using this code. That way, better comparing, if you start comparing two images, it is more complex, and comparing two binary bits, it is very easier here. But only thing is length is what it is taking more time, because it has no limitation on the size of the bit code that we have generated here, right? So again, it is the logical code, the content code, and then combining both of them, we have just gone with the sequence, and you can see a very huge fingerprint for the document. And as I told you, the future work is that resizing the fingerprint, what we have generated. I have done it for few examples, which you have seen here. So the conclusion of my presentation is that how important the documents, large amount of general information documents of printed text are sparsely located handwritten text with signatures are available today. Aim was to make the machine pervasive, that the document is extracts the vital information and the general information. Fingerprints are generated based on the position and structure of the vital information. And we assume that the vital information is present in the imposed layer. And fingerprint can be refined to reflect similarity ratio. Forged component identification was also, because as I told you, I myself would have not signed it in the same way. There is, if the document, the first document, let's say that I have an original document and somebody comes up with another similar document and says mine is original, right? Then we can identify very clearly like which one is forged and which one is the original document, because we would have generated the fingerprint for the original document. Because it is not the original document, it is a forged document. Document, it won't get the same unique code. It will have a different. They could be similar document, but they are not identical document, right? Transformation of binary codes into barcodes is, as I told you, we just did a binary code generation. We can convert that into barcode generation. That is the scope of the work which can be picked up by any other next researcher also. Right? Okay, thank you. Any questions? I think I can stop sharing and then I can see the questions.
Any questions can be posted on Q&A box.
I think there are no questions.
Yeah, yes, ma'am. I think maybe because we are running short of time also. Like we had planned it for due to the technical issue and then a signal problem and all, we couldn't finish it on time, ma'am.
No.
It's okay. I think right now what is shared is the feedback link for all the participants will be sent to your email ID within 24 hours, which I have intimated yesterday itself. And then you can, once you fill the feedback form, you will be receiving the e-certificate to your email IDs. Okay. Thank you, madam, for such an excellent session, ma'am. And you have enlightened us with your knowledge, actually. And you have gone into deep of like how that image documentation and all. So thank you very much, ma'am.
Yeah, thank you.
We have come to the end of today's webinar series on emerging trends in data science. I would like to share a quote by Albert Einstein. Education is not a learning of facts, but a training of mind to think. So we had been fortunate to listen to 3 eminent speakers, and I'm sure they have kindled our minds with spark of research. So on behalf of AMC College, I thank our esteemed guest speakers, Dr. Vandanaja, Dr. Sejal Santosh Nimborkar, and Dr. Sahana Gowda for sharing their valuable knowledge in spite of their busy schedule. I express my sincere gratitude to Executive Vice President AMC City Group of Institutions, Mr. Rahul Kalluri, and all the members of management for extending their support in organizing this webinar. I express my sincere gratitude to our respected principal, Dr. Prakash Duri, for being a constant source of encouragement and motivation. I am also thankful to the webinar coordinators, Mr. Ranjan Narlashetty and Mr. Mushtaq Ahmed for their technical support. I express my heartfelt thanks to the faculties, professionals, and students from India and abroad who have participated in the webinar series and made it successful. Finally, I thank all the faculties of Computer Applications Department for their valuable suggestion and cooperation. Thank you, everyone. Thank you for making it a success. Thank you.